Hi guys. Today we're talking about exact differential equation. So recall that a differential equation xy dx plus xy dy is exact if differential of m with respect to d of y is equal to the differential of n with respect to d of x. So with an exact equation, we need to test, with a differential equation, we need to test that the differential is exact. Once we've tested the differential equation is exact, then we expand the brackets. We expand the brackets and group the variables that have the x and y variables together. Please note we are solving the exact differential equation by the grouping method. There are other methods, but in this session we're going to be talking about the grouping method. So you expand the brackets of open bracket y d of x plus n open bracket xy d of y, and you group the variables that have the x and y together. The variables that are grouped together, we only need to pick one of the terms and differentiate it with whatever, with respect to the variable. So I'll show you an example to see what I'm talking about. So an example is, first example is solve the differential equation and then x to the power of y minus x, open close bracket d of x plus open bracket x, and then x minus x plus e of y dy is equals to 0. So the first thing we need to do is we need to test that the differential equation is exact. But also, before I proceed, with the logarithm rules, ln x to the power of a is equals to a ln x. So I'm going to apply that into here. So this gives me y ln x minus x d of x plus x ln x minus x plus e to the power of y dy equals to 0. So now I need to test that the differential equation is exact. So m is equals to y ln x minus x, and the differential of m with respect to d of y gives me ln x, because in this scenario ln x is a constant, and the differential of y with a constant is going to give me the constant. So with respect to y, it's going to give me ln x. N is equals to x ln x minus x plus e to the power of y. Differentiating d of n with respect to dx gives me, I'm going to differentiate this with the chain rule. So, the chain rule says that differential of u times v plus the differential of v times u. So u is x ln x plus x ln x. Differentiate ln x gives me 1 over x minus 1, and this is a constant, that's 0. So this equals ln x plus 1 minus 1. This equals ln x. So we've seen that the differential equation is exact, and now we need to expand the brackets. So y ln x minus x dx plus x ln x minus x plus e to the power of y dy is equals to 0. Expanding the brackets gives me y ln x dx minus x dx plus x ln x dy minus x dy plus e to the power of y dy. And then I group the differential equations, and I group the differential equation with two variables. So this has one variable because e to the power of y of differentiating with respect to y. This has two variables because it's x differentiating to the differentiating x with respect to d of y. This has two variables, x ln x, differentiating with respect to d of y. This has one variable and this has two variables. So I'm going to group them together. This gives me y ln x minus x dx y ln x plus x ln x dy minus x dy plus e to the power of y dy minus x dx. So I'm going to group those together again. That gives me x ln x minus x dy, then plus y ln x dx plus e to the power of y dy minus x dx is equals to 0. Now I'm integrating each variable. This gives me x ln x minus x dy plus y ln x dx. These are one, this is one group because they've got two variables between them. Plus the integral of e to the power of y dy plus the integral of minus x dx is equal to the integral of 0. So this gives us, we only need to pick one of the variable to integrate because they're exact. So I'm going to pick, I'm going to pick y ln x with respect to d of x. You can pick this as well, x ln x minus x with respect to d of y. You find out that it gives you the same equation. So I can do this as well. So integrating x ln x minus x with respect to d of y gives me xy ln x, because this is a constant, xy ln x minus xy plus the integral of e to the power of y is the same, e to the power of y plus, so plus x minus x integral of minus x with respect to dx gives me minus x squared divided by 2, and then the integral of 0 is c. And this becomes our solution. So we have solved the differential equation, and our differential equation is x times y ln x minus xy plus e to the power of y minus x squared divided by 2 is equals to c. And that's the solution of our exact differential equation.